I've created this chainmail object using two interconnected rings with a subdivision modifier added, then positioned so that they will overlap correctly when adding an array modifier for both the X and Y directions. Now, doing a cloth simulation directly on this object would be difficult, so instead we can add a simpler object like this plane and add a cloth simulation to the plane, provided it's got enough subdivisions and topology to affect our chainmail. Now, this next part of the demonstration is optional for those of you who already know how to set up a cloth modifier, so you can skip ahead. For everyone else, I'll take you through the basic process of adding a cloth modifier and simulation to the plane. We'll select the plane, add the cloth modifier to it. Now, I want this plane to be something like a curtain blowing in a light breeze, so I'll need the top of it pinned. I've created a vertex group, so let's assign this top row of vertices to that vertex group. If we switch over to weight paint mode, we should be able to see the difference in weight very clearly. We'll tab back into object mode, and we'll go into the physics data properties so we can see all of our cloth simulation settings. There are a lot of them, but we're really looking for just one setting here. And that's under this area, labeled Shape. Here we can tell the cloth simulation to pin a selected group. So we'll select our pinned group. Now this plane will act just like cloth, but we'll have to add a physics effect so that we can complete the simulation. I'll just hit Shift A and add a wind physics effect and position it in such a way that we can see the direction that the wind will blow. Now, because we're using all default sizes, the default wind setting for strength is really, really low. So we got to give this some decent movement. I'm going to bump this up to maybe about 500. Now, this should be all that is required to get the effect right. So let's play the simulation and watch the plane as it deforms like a curtain. So let's bring back our chainmail, select it, and add the surface deform modifier to it. Now this will sit at the bottom of any other modifiers that we've added. I'll select the plane as the deforming object. We've got to make sure we're on frame 1, click on bind, and play through the animation. Now you can see how the chainmail waves just like the plane, even though it's got all those other modifiers added to it in the stack above the surface deform. Now let's look at the settings for the surface deform modifier in a little bit more detail. Without unbinding the modifier, we can change by how much the object is affected by the surface deformation. By default, it's set to 1, which means it's going to correspond almost exactly to the target. If we lower this towards 0, we can dampen that effect until there's no effect at all. You do have the option to increase or decrease this strength dramatically over 1 and below 0 should you require it, but in most cases this is going to give you some very unexpected results. Now I've made a duplicate of this entire setup here, but in this one I've applied the array modifiers to the chainmail, so the only thing that we've got is the subsurface for the rings and the surface deform so that it can deform with the plane. I've created a vertex group to demonstrate that even when the mesh has been bound to the surface deform modifier, you can still select a vertex group to affect, or affect the inverse of this group. Let's unbind this for the moment and select a group before we bind the mesh. We have this option called sparse bind. This means that the group will have to be selected before the binding process. If we bind and then try to change the vertex group, that vertex group will not have an effect. Now finally, we've got this interpolation fall off, and this controls how smooth the deformation appears. Now it can be set between 2 and 16, obviously 16 being the smoothest, but in a case like this, the lower setting can actually have the more desirable effect, as setting the fall off too high can create artifacting. Ironically, it's because of how accurate the mesh will follow the target. Now we've got these nice big chunky rings, and we want to see them moving as if they were rings, not as if they were made of cloth. So I'm going to set that back to 4, and let's just play through that animation.